Hi everyone, welcome back. We found out before how to promote renewables, but how do we discourage carbon-intensive technologies such as coal? So in this video we'll talk about that. We'll talk about CO2 policies. And these policies make it hard, financially speaking, to emit CO2. And what this means is that it may become interesting for producers and for large energy consumers to lower their emissions. So this can be done by driving down their production with dirty technologies. They can do efficiency improvements in the short term, and they can also invest in cleaner technologies and renewables in the long term. So just have a look at how CO2 policies discourage emissions in the electricity sector. So without a carbon policy, the costs of CO2 emissions are not properly reflected in the price of electricity, and therefore producers don't have an incentive to reduce or to avoid emissions just because they don't have to pay for them. So the solution to this problem is to let producers internalize the environmental cost of their CO2 emissions. And that is to make them pay for the CO2 they emit. So that sounds good, right? Well, let's see how we can do that. Again, we have a choice between price and quantity instruments. And in theory, it should not matter which one you opt for. Both should, ideally speaking, result in that same emission reduction. In this video, because we have a cap-and-trade system in Europe, a quantity instrument will focus on this. So let's have a look. The EU Emission Trading Scheme, or ETS, sets an upper limit to the total volume of CO2 emissions, the so-called emissions cap. This limit is achieved by allocating this fixed amount of emission permits to polluters every year. And every unit of CO2 emissions, it has to be covered by such a permit. So the initial distribution or allocation can be done by an auction or allocated freely. And because reducing emissions is easier for some and more difficult for others, it has been made possible to trade the emission permits. This makes the permit price fluctuating, being higher when demand of permits is high relative to supply and lower when demand is low. The level of the emission cap is a policy choice. And the EU Emission Trading Scheme, for instance, reduces the volume of permits by 1.7% every year. So here we see a simplified version of the CO2 market. On the horizontal axis is the volume of CO2, and the vertical axis is the permit price. The orange line is the demand curve, and the blue line the supply curve. For clarity, in this graph, we don't consider trade between the producers at this point, but what we see as the supply of CO2 credits now is only determined the volume of credits that the government makes available. And therefore we present this as a vertical line. Demand, however, demand for credits, does depend on the permit price because the cost of reducing CO2 varies a lot between the different companies. And just think of it this way, the more it costs you to avoid emissions, the more you are willing to pay for purchasing credits so you don't have to cover. Okay, the intersection of the supply and demand curve determines the market price, which you can see here. And price changes can be caused by either shifts in supply or in demand. When demand for permits is high, in times of economic growth, for instance, the demand curve shifts to the right and the market price goes up. And reversely, during a recession, the demand curve shifts to the left and the price goes down. And the supply curve moves to the left when the government lowers the emissions cap. And as there are now fewer credits available, the producers who are willing to pay more for them set the price. This means that capping total emissions creates a market for CO2 permits, and the price in this market affects the electricity market. Let's just see how that works. So we know that in day-ahead electricity markets that we've discussed before, that producers there bid their electricity at variable cost. The bids are then ranked from the lowest to the highest in order to meet demand at the lowest possible cost. Let's consider 4 example plants: a wind farm, coal plant, a nuclear plant, and a gas plant. Okay, the wind farm, to start with, has virtually no variable cost. The wind blows for free. Coal and nuclear have fuel, and they're relatively cheap, let's say 12 euros and 15 euros respectively. And the gas plant has the highest variable cost, Gas is expensive, let's say 40 euros. So if they bid their electricity in at variable cost, let's say in a power exchange, they would be ranked like this, from the lowest to the highest variable cost. Okay, let's just recap some market basics. Okay, we call the last plant needed to satisfy demand the marginal plant, and that is the one that sets the market price. Every plant that runs receives that market price, and that means that the other plants that run make an operating profit. Those can be used to recover fixed costs or to make new investments. So, how does a CO2 price affect the ranking of the power plants? Well, CO2 costs are also variable costs, just as the fuel cost, and because the emissions of a plant are directly related to the plant's output. The more emission-intensive a power generation technology is, the more the producer is affected by this CO2 price. And as a result, electricity generated from fossil fuels becomes more expensive. In this case, wind and nuclear power are both nearly emission-free and therefore are not directly affected by this cap-and-trade system. On the other hand, producing 1 megawatt hour of electricity from coal emits, well, somewhat less than a ton of CO2, while natural gas emits only around half of that. Let's, for now, assume the CO2 price at 12 euros per ton. The consequence is that this makes the coal plant more expensive than the nuclear plant. As a result, it shifts to the right in the merit order, which makes it run less often. So when the carbon price would increase, at some point electricity from natural gas will be cheaper than from coal. And that is just because coal emits more CO2 per megawatt hour produced. In this example, a carbon price of at least 60 euros per ton would be needed to achieve this change in the merit order. Okay, let's just look at other effects of a carbon price. Here we have the supply curve we just ended up with. And let's just add, dashed, the supply curve that we had before the price was added, the CO2 price was added. Let's now look at demand. Well, what you see is it doesn't change very much in the short run. Nevertheless, the electricity price goes up quite a bit, and this provides a signal for consumers to lower their consumption in the long run. It also leads to an increase in the operational profits for low carbon technologies, which improves their business case. So this mechanism encourages the new investments in low carbon technologies. And as a counterpart, when operating profits of high carbon technologies become too small to cover their fixed costs, they may actually be dismantled. Okay, in theory, an emissions trading scheme efficiently reduces CO2 emissions to the desired cap. And that is because companies can trade the emission credits and various energy-intensive industries are in the system, which means that the reduction can be achieved where it is cheapest. However, in reality, the economic crisis led to a surplus of permits in Europe. And as a consequence, we see a strong decline in the CO2 price, which we see in the graph, and low prices were there since. And well, together with high gas prices in Europe, coal, the dirtiest technology, remains economically attractive. Moreover, CO2 prices may be volatile and hard to predict due to uncertain future developments of supply and demand. And considering that investments take time, that the power plants have long lifetimes, producers can just not be sure whether their investment will pay, and they rather wait. So together this leads to serious concerns of lowering CO2 emissions in the long term. So will the CO2 price lead to appropriate investments over time? Well, the current plan is to improve price stability by taking out a surplus of carbon credits when demand is low, just to avoid these heavy price drops. And they would be reintroduced at a later stage when demand is higher. Another solution would be a price floor in the CO2 market. We've now looked at two main fields of policies, renewable energy policies and CO2 policies, and both aim at stimulating investments in renewable energy, reducing CO2 emissions. But there are more options to reduce the energy that we consume. In the next clip, we'll look into policies aiming at energy efficiency improvements.